Hello, my dear warriors. Welcome. Hello, Saida. Good evening. Hello, Bharat Faria. I'm very good. Hello, JV. Hello, Simran. Hello, Naji. Hello, Ms. Doctor. Good evening, Lances. Nice to see all of you out here in the second lecture of the modern physics. And today's lecture is all about atomic physics. And my name is Shreyas. I'm your physics master teacher. I'm leading the JEE division out here at Vedantu, teaching for almost like more than a decade now. And I have done my graduation from NIT Nagpur. I did my research from IIT Bombay. And lots of students. I'm very happy that they are in IITs, NITs, all the AFMCs, all the AIIMS. And I'm so glad that I have taught them. And I'm hoping that you too will be adding to these numbers out here. And in the days to come, you're going to make not just me proud, but also your parents, your friends, your entire colony, your entire town, or even your state proud. Thank you so much for joining in, guys. This is Atomic Physics lecture where we are going to discuss the models of atoms and more specifically the Bohrs model and the hydrogen spectra related concepts as well. This is a theory class. There will be some questions, some problems, but you will see majority of the problems will come in the problem solving class. Okay, so let's begin the class, guys, and thank you for smashing the like button already. Like I can see in the chat box, so many people have started posting up and lighting up the chat box with the fire. Very good, guys. Oh, by the way, today we are going to see some amazing simulations like I promised you on Telegram. So if you have not yet joined the Telegram channel, make sure you join that. The link is there in the description box over here. Okay, the Vedantu Telegram channel. If you want to take the crash courses, those links are also there right over here. So let's begin, guys. Can I make a timetable for the session? Yes, acing, I will definitely do that from next week. This week we are just trying to manage, and because these are the first few lectures of this channel, so we're just trying to get things into routine. Next week I'll be posting a timetable just at the start of the week. Okay, somewhere around Monday I'll post a timetable for the entire week. But you can take it for granted that I'm going to start with, because I've started with modern physics, I'll complete modern physics. So the next lecture will be on nucleus, and then after that will be semiconductors and stuff like that. So that's how we're going to proceed. Okay, chalo, let's begin, guys. Thank you so much. Good evening, Virshu. Hello, Nanzias. Hello. Nice to see all of you. Somebody saying I'm missing Pandu as the example. I'm pretty sure Pandu will come very soon, guys. Okay, now let's talk about atoms and atomic structure. Now let me tell you, atomic structure is such a big topic and it has a big history. Every person has given his or her own version of what atomic structure is. Like you see in some movies, like one person says, oh, this is what happened. Then they show from some other perspective, you know what, this is what would have happened. So same way, atoms were perceived very differently long time back. Long time back, people thought there are these small particles which are, you cannot divide them. That's it. These were called as kans, or basically just tiny mini particles. And then later on, people understood that, wait a minute, even these particles are made of even more tiny particles. And then those particles are made of even more tiny particles. So that's how the theory progresses. And a lot of people have made contributions in the atomic structure. And these theories have gained a lot of momentum in the last 200 years, I would say. So in the late 1800s and 1900s, you will see a lot of theories of atomic structure being populated and being very popular. But people knew about tiny particles much before Christ. You can see 500 BC. That's when people postulated about, tiny mini particles. And only in the last 200-300 years, you can see things gaining up pace. So let's see how many of you know this general knowledge question, guys. Who discovered electron? Type it. Who discovered proton? Type it. Who discovered neutron? Now, let me tell you, these kind of questions can also come in NEET as match the following. Like they can give you a table, A, B, C, D or something, P, Q, R, and here scientist names, here the discoveries. It might be simple, it could be difficult. And then options will be given. A goes with P, B goes with R, Q goes with C or something like that. So you will have to select one of the options. So match the following type of questions also come sometimes in the NEET exam. Alright, so students have started answering. Jayashree, the homework questions answer, right, is there in the Telegram channel. I have posted the solution of the homework question. So please download that PDF, join the Telegram channel. Link is there in the description box. Goldstein, Chadwick is neutron, J.J. Thomson is very common. Yes. So Thomson was the guy who discovered electron in 1897. That's really far away. Okay, long time back. Rutherford was the person who discovered proton in his famous gold foil experiment. So I have my own version of this gold foil experiment. I think Rutherford wanted to gift something to his wife. He bought a lot of gold, and then I think he fought with his wife one day, and then he's like, why to give my wife this golden ornaments? So he's like, okay, let me make a gold foil and let me pass alpha particles. So he was a legend, and then he saw one new particle being discovered, and that was proton. So that's what legends say, but I don't know what's the reality, guys. This is what the legend story is. Okay, so he put gold to very nice use for the sake of humanity. So guys, I don't know whether you guys are going to do something like that crazy. I don't know. Okay, then you also had Chadwick, who basically discovered neutrons. Okay, so neutrons was discovered by Chadwick in the year 1932. That was the last discovered particle in the three of them. So electron first, then comes proton, then comes your neutron. Now the first theory, which is very significant, is Dalton's theory. But Dalton's theory did not give a very good picture of atom, but nevertheless you should know about it. So what Dalton said is that, let's go through this one by one. All matter is made up of tiny indivisible particles. They are called as basically atoms. So atoms are nothing but tiny indivisible particles. Obviously this is wrong, we know that. Actually speaking, this is wrong. You can divide an atom. It's made of small furthermore particles. All atoms of specific element are identical in mass, size, etc. and properties. However, atoms of different elements are having different properties. So all atoms of a specific element have identical properties. All atoms of different elements have different properties. Makes sense. All the water molecules are very similar. All the molecules of gold are going to be very similar. All the molecules of hydrogen gas will be similar. And you can see hydrogen will be different from water molecule. So that's what he said. That is perfect. So we give him marks for that. It's like we are the teacher over here and this is a student who is writing something. And we are like, no, this is wrong. I know this is wrong. Okay, this is fine. You get +1 marks. So you feel happy about it, right? Giving marks as a teacher now or cutting marks as a teacher. Okay, so no points here. First point over here. Okay, great. Atoms can neither be created nor destroyed. Furthermore, atom cannot be divided into smaller particles. This is wrong, guys. Atom cannot be divided is wrong, and atom cannot be created, destroyed. This is wrong. We know that in nuclear explosions, etc., mass can be created, mass can be destroyed, nucleus can be created, and all those sorts of things can happen. So that's why this is also partially wrong, saying that atoms cannot be destroyed, and also you cannot further divide it into smaller particles. So 0 marks for this point. Are you happy? As a teacher, giving 0 marks over here, 0 marks over here, 1 mark over here, guys. You being the evil teacher now. Yes, friends gamer, you can. Atoms of different elements can combine with each other to form whole number ratios in order to form compounds. That also makes sense. Like if you want to make a water molecule, then 2 hydrogens mix with 1 oxygen. It's not like 1 hydrogen and half a hydrogen mixes with 3/4 of oxygen, or half a hydrogen mixes with 1/4 of oxygen to give some compound. No, whole numbers only. So this is fine. We give him full credit, full points for this particular thing. They can mix in fixed whole numbers. So this is perfectly fine. Atoms can be rearranged, combined and separated in chemical reactions. That is also correct. Like whenever chemical reactions occur, the atoms can separate, they can combine with another molecule, another atom to form newer compounds, or the compounds can be broken down. So this is also correct, and you can give marks for this. But these are only few things about the atom. There were so many other things which were not explained by Dalton. Okay, like the flow of or the conduction of electricity, or even the gold leaf experiment, or the hydrogen spectra, and Zeeman effect, and so many other things which could not be explained via Dalton's theory. So that's when the next theory comes. But before that, let's see how many of you are paying attention. All atoms of a given element have identical dash, including identical dash. Put up the answer in the chat box. Savanan, nice to see you, bacha, and hopefully this is not your last. You keep on attending the classes till the end, because this is a continued series on the NEET English channel, guys, for all of you, and you should call your friends too. This is an exclusive NEET English channel. We already have a JEE English channel. There is a NEET English channel out here. So Pandya saying A, Pravina saying A, Ashika saying A, Sampath saying A, Morpati saying A, everybody saying A. Very nice. Looks like you guys are all very attentive students. Very good, guys. Keep it up. Lot of questions theory are going to come up. Very nice. I want to see this. I want to see this till the end of the class. Very good. Correct answer is properties and mass. They have all the atoms of a given element like gold, silver, iron, or anything, even calcium or hydrogen. They have same properties and same mass. Weight, volume, nah, they can be different weight. I mean, you can have more gold here, you can have less iron there. No. Volume and properties, no. Temperature and pressure, how is that true? Properties and mass. Okay, now talking about the different atomic models. So we are going to first go towards the Thompson's model, and then we are going to go towards the Rutherfords model. Okay, before going to the Thompson's model, one thing I want to mention is that long time back people knew that there are conductors. What is a conductor, guys? Bus conductor? What is a conductor? Bus conductor? No, electrical conductor. What is the meaning of electrical conductor? It conducts. What does it conduct? Electricity. What does it mean by conducting electricity? When I say electricity is being conducted or electricity is flowing, that means there is some current flowing in it. When current is flowing, it's nothing but the flow of charges. And the conventional direction of the current is the flow of positive charges. The direction of the flow of the positive charges. But it was proved experimentally by many people that actually when current flows, the positive charges do not move. So the positive charges do not move, but it is the negative charges. It is the negative charges which actually move. And the negative charges move in this direction. The negative charges move in this direction. The positive charges are basically going to be at rest. So if negative charges go here, it's as good as saying positive charges are going there. If negative goes here, it's as good as positive going there. Is that understood? Everybody clear about this? Negative charges go here. So actually, it's as good as saying positiveness is going the other way around. So they knew this, that the flow of current is because of the negative charges in it. They just didn't know that it was electron. They just knew about a concept called as negative charge. They just didn't know that it was an electron. Is that also understood? Very nice. Now, if this much is clear, in your head, understand one more thing, that if electrons can move very easily, it's because of the fact, or the negative charges can move easily, it's because of the fact that they are loosely tied. So the negative charges are able to flow because they are loose, they are free. They are free or they are loose. That's why they are able to move easily in that conductor. That positiveness is not able to move so easily. So it is like a fixed thing. That gave Thomson an idea. Oh, maybe atom is like a watermelon. Like in this very famous movie 3 Idiots. How many of you have seen that movie 3 Idiots? Where, the principal of the college, or basically the dean of the college, Boman Hirani, who is playing that role, he says, life is like an anda. Life is like an egg. Right? So you know what Thomson said? Thomson was like, life is not like an anda. Atom is like a watermelon. Atom is like a watermelon. That's what Thomson said. You cannot forget this statement now. Okay, great. Awesome. So many of you have seen that. So in that watermelon, the red part, everybody has tasted watermelon 100%. There are seeds which you just spit it out, hai na? And you might have heard weird stories as a kid. If you eat those seeds, then plant will grow in your stomach. Watermelon plant will grow in your stomach. And people used to get scared. But now you guys are biology students. You're going to become doctors. You know this is all not true. This is just chumma there to scare you. Okay? Anyways. So you have those seeds. Those seeds can be easily plucked out. And they can move here and there. So he thought the negative charges are like those seeds. The red part is positive charge. Red part positive. That seed is negative. Red part positive. Seed is negative. Those seeds can easily be plucked out and they can flow. That allows the conduction of electricity. It is also called as pudding model, plum pudding model, where those cherries or those teeny mini things are electrons and the rest of the cake is your positive charge. He also said that the amount of positive charge is distributed throughout that atom. It is spread. It's like a paste spread everywhere. It's like a gel or a paste spread everywhere. But the total positiveness is the total negative charge. That's why every atom is neutral. Every atom is neutral because the amount of positive is equal to the amount of negative. That's what he proposed. I hope this is clear. Everyone? Yes. Chumma means, what is the meaning of chumma? There are many meanings of chumma, but the meaning of chumma that I wanted to say, or I am trying to say, everybody knows. Come on guys, what is the meaning of chumma? Come on, all the Tamilians, all the Telugu people, all the students from Bangalore, Kerala should know this. Yeah, nothing. Very good. Nothing. Awesome. Great. Kiss. Sampath, which movies are you watching, man? Okay, nothing important. Very good. Looks like you guys know some definitions. Great. So that is nothing but your Thompson's atomic model. Positive equal to negative. Electrons can flow easily. The positiveness is spread everywhere. The teeny mini particles are electrons. That was Thompson's model. Then, in this Thompson's model, there were some problems. See, Thomson was a great guy. Thomson said, life is like an anda. He said, atom is like an watermelon. But there was a problem in his theory. What was the problem in his theory, guys? The problem was he could not explain why are the spectral lines coming, just like it happens when teacher is asking Viva questions. Explain why there are spectral lines in the form of series as in the case of hydrogen atom. Thomson was like, I don't know, ma'am. Sorry, ma'am. Then teacher was like, it could not even account for the scattering of alpha particles when Rutherford used the gold which was meant for his wife. Instead, he used it in the gold foil experiment. Why is it not able to account? Thomson was like, sorry ma'am, I can't say, I don't know. So then gone. Thompson's theory, tata, bye. Okay, understood? Very good. Is that clear? These were the limitations. What were these? Limitations of Thompson's model. You should know both these things. So one, it could not explain the origin of spectral lines. Second, it could not explain the origin or why scattering of alpha particles happens in the Rutherford experiment. So who explained? Like it happens in every Viva. There is one student saying, sorry ma'am, I don't know ma'am, I'm so sorry ma'am, I don't know. Then others, ma'am, miss, I know. So who was that guy? That was Rutherford. He came and he's like, I know, I'll explain. So Rutherford did an experiment and let's see what that is. So before that, let me show, this was the model. This is like a cake or watermelon of Thomson. These teeny mini dots are electrons. If what Thomson said was true, if you pass alpha particles, what is alpha particles? Positively charged helium nucleus, right? Doubly ionized helium nucleus. Then it just flows through it. There is no deflection. There is no turning because overall it is neutral. Wherever it is positive, that much negative. So it's basically a neutral body. So there is no deflection as such. But this is not what was found. This is not true. This is not what happens. Actually, what happens is this. This is basically now the Rutherford's model. Let's have a look. This is exactly how an atom's nucleus looks like. So this is nucleus. You can see it's made up of a lot of protons and neutrons out there. It's heavily positively charged. And then the moment you turn on alpha particles, this is the gold foil. You can see this is the gold foil. See the way alpha particles are getting deflected. Do you see the way alpha particles are like, oh my god, what is this? What is this? This is like the principal of your school. These are the kids. The kids who are going from the side, they are going aram se, chill madi. But these people who are going near the principal, oh my god, principal is coming, run, 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 run. See this? This kid ran away, this kid ran away, this kid ran away, this kid ran away. That kid which will go directly towards that nucleus, sometimes it will happen, it will take a U-turn. Very rarely it will happen by chance, okay? It will almost take like a U-turn. So most of the alpha particles will go undeviated. Some alpha particles will get deviated slowly or slightly. Very few alpha particles will get deviated by a lot of amount. This proved that there is something heavily concentrated at the center of the atom. This means that there is something really heavy and very nice positive charges there, which is deflecting all these alpha particles. Very few alpha particles go head on, bang onto it. That's why they go U-turn. But otherwise, most of the atom is empty. That's why all these alpha particles are able to cross this atom. So you can see this as a whole. These are the nucleus. Most of these violet darts are able to pass, but very few of these violet darts are basically deflecting by small amounts. I hope this is clear. Exact example, Prem. Is alpha particle positive or negative? It is positive, MS Doctor. It's basically helium. Pluck those electrons. What does the helium have? 2 protons, 2 neutrons and 2 electrons. Take away the 2 electrons. What will be left? 2 positive charges. That's an alpha particle. 2 positive charges basically with 2 neutrons. That's all. I hope that is clear, guys. Okay. Susanta, I'll tell you one simple thing. There is an option where you can take the negative. Just take the negative of this. That's it. It's simple. Just invert those images. That's it. Everything will become inverted. You can definitely make notes or you can take printouts. Okay. So now that you know what is Rutherford's experiment. So there is alpha particles, gold foil over here. It will pass. Most of it will pass. Some of them will get deflected by small amount. Very few will get deflected by a large amount. From that, he was able to conclude most of the atom is basically, empty. The whole of the positive charge is almost the entire mass is concentrated in a small central core. So most of the positive charge, most of the mass is concentrated in a small region. Most of it is empty, right? That is one of the conclusion. Next conclusion, the nucleus is surrounded by electrons. You can see these electrons are surrounding these, nucleus. These electrons are surrounding the nucleus, and these electrons are spread in the remaining part, leaving plenty of empty space over there. There's a lot of empty space. That's why those alpha particles were able to easily pass through the atom. Are everybody able to visualize this? Are you able to get the feel of an atom now? Next important thing is that he also proposed that, although I have not written it down over here, these electrons revolve because of the centripetal force, because of the electrostatic force or the centripetal force. These electrons are able to revolve around the nucleus. Whenever things go round, what happens? There should be some force which provides the centripetal force. In this case, it's the electrical force. Negative, positive, attract. So the attractive force of electrostatics provides the centripetal force for its revolution around that nucleus. That's what he said. He did not say anything about the orbits or anything. He just said the electrons just go around the nucleus. That's all. And the force is given by the attractive force between the electron and the nucleus. But even Rutherford failed. So first student was like, sorry miss. Then the other student, who was the other student? Rutherford. He was like, ma'am, miss, I know the answer. He proposed something, but even this failed. Even this theory failed. Even this theory failed. You know why? Because he was able to say that, okay, electrons revolve around the nucleus. Then the problem with that is, when the electrons revolve, because they are going in circular path, they are accelerating. Yes or no? Like Prem Kumar said, v square by r is the acceleration. Now because it is accelerating, it was also said by other theories, Lorentz and Maxwell's theory, which said that whenever a charge accelerates, it should emit radiation. Whenever a charge accelerates, it should emit radiation. That means it loses energy. That means as the electron revolves, it loses energy. It becomes weak, and it should fall into the nucleus. But that's not what happens. So, according to the theory, because it is accelerated towards the center, then this should emit radiation energy continuously. Therefore, a revolving electron should emit energy, and hence the radius of the path should keep on going, decreasing, and ultimately it should fall into the nucleus. How can an electron fall into the nucleus? If electron falls into the nucleus, explosion, big explosion, everything will be destroyed. It's like a nuclear explosion, guys. That should not happen. It should not happen. That is very, very dangerous. If an electron falls into the nucleus, gone. That is not possible. So he was not able to explain that. Number two, Rutherford's atomic model, if it is true, then the electron can revolve in orbits of any possible radius. He did not say anything about the orbits. Yes, he did not say anything about the orbits. What about the orbits? So all possible radii are possible. Hence it should emit continuous energy spectrum. But how does hydrogen possess line spectrum? If it can have any kinds of orbits, then the energy which will come out of it will also be any amount. If energy also can be any amount, the spectrum which comes, we'll be talking about it, will be continuous. But actually it was found the spectrum is not continuous. It is like a line, distinct spectrum. Why does that happen? Rutherford did not have the answer. That is the limitation. Okay, so let's see how many of you are able to answer this question. Which of the following is not a part of J.J. Thomson's atomic model? Which of the following is not a part of J.J. Thomson's atomic model? All the new students who are joining in, make sure you hit the subscribe button and also hit the like button, guys, because you will otherwise not get notifications, and that's how YouTube algorithm works. You'll miss the classes. You'll be like, I know this class is at 5. You'll forget it. So make sure you stay subscribed and also hit like button. Both things are mandatory and necessary so that you do not miss any classes and also show your support to the channel. Okay. Great. And if you have missed any part, make sure you go back a little bit and come back. What is the line spectrum, Leaf? Yes, I'm going to come to that. Spectrum, we are going to talk about it in detail. But for now, just remember the word line spectrum and continuous spectrum. It does not explain why line spectrum happens. According to that, because any radius is possible, any continuous energy is possible, so you will get a continuous spectrum. But that is not true. D for doctor? Very good. Which of the following is not a part of Thompson's model? What did Thompson say? Life is like an anda? No, he said atom is like a watermelon. Watermelon means completely full. No, it's not empty. So he said atom is hollow sphere. No, he said atom is completely full. So that is not a part of Thompson's model. Atom is a gel of positive charge. Yes, the red part of the watermelon is the gel of positive charge. Electrons help in conduction. Yes. Atoms have embedded negative charges. Those are the seeds. So these are the seeds. These are the seeds of the watermelon. These are the seeds of the watermelon. Okay. And this is, atom is a gel of positive charge. So that is the red part of the watermelon. Electrons help in conduction of electricity. That's something which I told you already. Next question. Rutherford alpha particle experiment shows that most of the alpha particles pass through unscattered, whereas few of them are scattered through large angles. From this information, what does it tell you about the atom? What does it tell about the atom? Atom is hollow, the whole mass is concentrated at the center, or nucleus is positively charged, or all of the above. Yes. Anda means egg. Okay, MS Doctor. Anda means egg. Okay. The white egg. Yeah. Okay. Great. D for doctor also. D for AIIMS Delhi, right? D also is AIIMS Delhi, guys. Yes, yes, very good, very good, very good. Proud bacha, super duper, very good. Amazing, all of them. Because all of them, most of them are passing unscattered, that means empty space is there, or else they would deviate. Very few are deviating by a large amount. That's because nucleus is repelling them and it is only there at some locations. So that's why all the mass is concentrated at a very small space, which is called as the nucleus of that atom. Very nice. Now let's go to Bohr's model. Now comes Dawn. First student said, sorry ma'am, I don't know the answer. Next student said, ma'am, I know the answer. Then he also got one tight slap. He was also not able to answer. Then comes the Dawn. Then comes the Dawn. Thalaiva comes like this. Who is the Thalaiva? Bohr. Who is the Thalaiva? Bohr. And he's like, listen, I will tell you guys how this question has to be answered. And Thalaiva is like, Bohr is like, listen, there are some things which I discovered. There are certain things which you guys are doing wrong. I will tell you what is the correct thing. Okay. So, postulate 1, that means his proposition was, electron in an atom could revolve in certain orbits only without emission of radiation. Remember, whenever charges accelerate, they basically emit radiation. But there is a but. And what is that but? The but is, if those orbits are basically stable or generally called as stationary orbits. Stationary not because it is not revolving, stationary because it is stable, it is stationary energy wise, then it will not emit any radiation. Not emit radiation. Only in those special orbits. Why only in those special orbits? That's none of us concern. Don't worry about it. That goes into quantum mechanics. But he said that there are only fixed orbits. Meaning, think of it this way. If Bohr's postulate were not obeyed, then the electron can revolve here also, 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 here also. So it's like a continuous value of radius that it can revolve. But Bohr said, no, this is not true. Actually, what happens if this is the nucleus? Electron can revolve here, nothing in between, here, and then here. So only fixed number of orbits are there, not any random orbit. Here it is not allowed, here it is not allowed, here it is not allowed. So that's what is being proposed. Everybody clear? Everyone? Understood? Let's move on to the next postulate. The next postulate is, in these special orbits, in these stationary orbits, in these stable orbits, the angular momentum. Now you will be like, sir, what the hell is angular momentum? I forgot. Just quickly revise. Okay, I'll revise. If you take, teacher would have thrown sometimes a duster on your face. Has anybody got that? Duster, pen, chalk. Chalk, I think, very common. The session started, Iman, at 5 o'clock. Yeah? So, thrown a duster on your face. Duster or chalk has some mass. It also has some speed. So, more the mass, more the speed, more the momentum. That's it. On your face, nice slap you will get. Yeah? So, if it was duster, more mass, more momentum, you will get hit badly. That is linear momentum. Momentum of translation, that is linear momentum. Correct, very good. Now imagine you take that duster or that chalk, you hold it like this. You hold that duster like this and you hit it like this on somebody. You take it like this and hit it. Do you see there is momentum and it is at a distance? If I hold it here and I hit it on somebody's face, no, not much of impact. But if I hold that same mass over here, large distance, you will see large impact. Large distance, large momentum, large impact. So that is angular momentum. I am showing that momentum at an angle. That's angular momentum, guys. That's R into momentum. That is angular momentum. Clear? Pain is also more. Very good, Kanista. Very good. So that is angular momentum. So angular momentum is nothing but R cross P. R is distance, P is linear momentum. You can also write it as R into M into V, which is also MVR, one and the same thing, guys. MVR, that is NH by 2 pi. What is H? Planck's constant. Last lecture I have told you, 6.6 10 to the power minus 34, right? In SI units, that's the Planck's constant. 2 pi, pi is 3.14. What is N? N is basically called as your principal quantum number. What is it called? Principal quantum number. Like the electrons which revolve, they revolve in shells. There is the first shell is called K. The next orbit is called L. The next orbit is called M shell. The next orbit, or where the electron can revolve, is called as the N shell. For K shell, the principal quantum number N is equal to 1. The next shell, it is 2. Next shell, it is 3. Next shell, it is 4, and so on and so forth. You can use the remaining alphabets. K, L, M, N. So my name is Captain Shreyas Bacha here, right? People call me Captain or just Capto. Yeah, Shreyas. Yep. Very good. He said angular momentum is NH by 2 pi. That's it. Whenever it is NH by 2 pi, okay. You are not NH by 2 pi, gone. N is any integer. 1, 2, 3, 4, get on the dance floor. You know? So 1, 2, 3, 4. Only integers. Don't put 1.1, 1.3, 1.4. No, not allowed. Alright. Moving next. Bohr's model, third postulate, guys. Okay. We now know electrons go in orbits, fixed orbits, no radiation of energy, and in these orbits, angular momentum is NH by 2 pi. Now what happens when the electron goes from one orbit to another orbit? It gets excited or de-excited, excited or de-excited. What happens then? Yeah, many orbits are there, GV, but not all orbits will have electrons. It depends on the atomic structure or the configuration. What is the atomic number? So smaller atoms, few shells only might be filled. As you go big atoms, then more and more shells will be filled. Okay? But even the largest of the largest elements in the periodic table, hardly some 4 or 5 orbits, that's all. Okay. Now what happens when an electron shifts the orbit? How can it shift the orbit? I'll tell you. Imagine it is in some shell. It could be, let's say for example, shell number L. And this is, let's say, shell number M. Let's say this is shell number K. As you go to higher shells, K, L, M, N, energy will also go up. What happens? Energy of the electron also increases as the orbit increases, radius increases. Imagine that there is an electron over here. And there are two possibilities now. Electron can get excited, electron can get de-excited. If an electron gets excited, that means it has to go over here. It gets excited. If it gets excited and it goes over here, tell me one thing, should you give energy or should you take away energy? If you are going to, excellent. Let's say this electron loses interest, demotivated. It loses interest, it gets de-excited. This is de-excited. If it gets de-excited, it is going to lower energy. When it lowers its energy, it will release something. Like when you get demotivated, what happens? When you get demotivated, what do you release, guys? Frustration, right? Anger. You become angry. Same way, when an electron becomes de-excited, it becomes frustrated, it becomes angry, it releases photon. Okay, I hope this is clear. This will basically release a photon. Now, what you should understand, that whatever is the energy of the photon which is absorbed or released, exactly matches the energy difference between the two shells. So, if the photon gave 5 joules of energy, example, then the energy difference between these two shells will be 5 joules. If the energy difference here is 3 electron volt, when the electron jumps over here from this orbit to this orbit, a photon of how many electron volt? 3 electron volt will come out. Understood? Everybody? So that is the reason why I say that the energy difference between the orbit is equal to energy of the photon, is the energy of the photon. So energy difference could be E1 or something, En1 minus En2. En1 minus En2 is energy of the photon, which is just hf. What is f? F is the frequency. F is the frequency of the light which comes out of it, or the frequency of that photon. Using this only you get this. So usually some books use nu, but I do not use that symbol nu because it is confusing with velocity. So I'm going to use the symbol F for frequency. In chemistry, nu is used because speed is not there in chemistry most of the times. But in physics, nu often resembles speed v. That's why we use the symbol F in physics. Everybody fine till this point? Okay. If you are in NEET AI Live, then don't buy test series, bacha. It is already a part of your curriculum, Vignesh. Okay, so it will be done. So don't buy the test series. Test series is only for those students who are not a part of Vedantu as of now. Thank you, Sarvana. J Advanced test. Oh my God, is it? Oh my God, oh my God. Okay, I will go live after this class for J Advanced. Okay, bacha log. All right, moving on. That is scary. I mean, 4th of June. Somebody just make a video, yeah, of me right now and just post it and tag me on Instagram and share it across. So guys, J Advanced 4th of June, the dates have been announced. Okay, I might have to check it officially, but that's what the students are saying. So if there is a JEE aspirant, please make sure that you share this message and probably tag me on Instagram as well. Okay, thank you guys. Okay, now what about the radius and the speed and the energy? Radius and the energy. Thank you, Himanshi. That's my whole motto, guys. So when I came on this channel, the only reason was to make things very clear, to make things interesting for all the students. So guys, I don't want to teach physics. Trust me on this. I want you to enjoy physics. The moment I start teaching physics, then you will not enjoy it, you will not learn it, you will not score marks. So here I am there to make you fall in love with physics and help you get that required percentage, required marks in boards, in NEET exam, so that you become successful doctors. That's the only purpose of me on this channel. Physics you can learn from anywhere, but here I am making sure that you become doctors. That is a bigger purpose why I'm here. Now, how do I calculate this radius? How do I calculate this speed? How do I calculate the energy? There are formulas, but what is the principle, or what is the theory behind it? What is the derivation behind it? We don't have to go too much in detail. Just have a look at how things are done, guys. Okay, observe. See, electron is going round. Electron is going round around the nucleus. The nucleus is positively charged. Okay. How much charge is there in the nucleus? How much charge is there in the nucleus? How much ever protons are there, that much charge. Because neutrons don't have any charge, right? Only the protons have charge. Okay. How many protons are there? As many atomic number. Whatever is the atomic number, correct? If it's hydrogen, it's 1. If it's oxygen, then it is different. If it is helium, it is different. If it is iron, it is different. So it is completely based on the atomic number. Very good. What is the atomic number symbol? Z. Z is the symbol. So can I not say the charge on the nucleus? Charge on nucleus. The charge on nucleus is basically number of protons multiplied by the charge of a proton. Charge of a proton. The number of protons is Z. The charge of a proton is E. This electron has a charge of negative E. So that's why this proton, this electron will attract each other. So definitely there will be an electrostatic attractive force. This is the force of electrostatics. This is the force of electrostatics. This force of electrostatics, how much will it be? K, your Coulomb's constant, into Q1, Q2, into Q1, Q2, divided by distance. Distance is also the radius. Distance is also the radius square. And this force will be by Newton's law, because it is going in circular path, because it is going in circular path, because it is doing uniform circular motion. Shouldn't there be centripetal acceleration? Shouldn't there be centripetal acceleration? So force is mass into acceleration, guys. Force is mass into acceleration, my dear students. Very good, very good. Now, what I'm going to do, K is nothing but 1 by 4 pi epsilon naught. Q1 is ZE. Q2 is nothing but E, magnitude wise only. I'm just taking the magnitude of the forces divided by R square is equal to mass of the electron is equal to mass of the electron. Centripetal acceleration is V square by R is equal to V square by R. Everybody with me? This is equation number 1. This is equation number 1. The second equation, you get it from the Bohr's previous postulate, which I just gave it to you over here. Angular momentum is nh by 2 pi. Angular momentum is nh by 2 pi. So mvr is nh by 2 pi. This is your second equation. Now solving equation 1 and 2, you get the value of velocity and you get the value of radius. Solving these two, you get the value of velocity and radius. Don't worry about it. It is very simple to do it even at home. I want you to try it out just for boards, but for our NEET perspective, that derivation is also not important. When you solve it, what you get is very important. The final result. Now you might have seen the final result in many books given like this. And I have seen many students trying to by heart this. How many of you have tried to by heart this and successfully failed? How many of you have tried to by heart this and successfully failed? Okay, so Bhadra, what has happened over here? This was force. Force is mass into acceleration. Force is mass into acceleration. Force, remember Coulomb's law. K, charge 1, charge 2 by R square. Charge 1, ZE. Charge 2, electron, so E. Distance is R, I have put it. Acceleration, circular motion, V square by R. That's it. That is equation 1. Another equation is angular momentum. MVR is nh by 2 pi. That's all. This is just angular momentum equation. From where did I get it? From here. MVR is nh by 2 pi. Bohr's second postulate. This is nothing but angular momentum. Is that okay, Bhadra? Yes, many of you? Okay, so this has to be solved. I mean, you can solve it easily. Take the value of V from here, put it here, eliminate V. So V and V, you will just get R. Then put R from here, you will get V. So it's just simultaneously solving it. So guys, you don't have to by heart it. Aren't you relieved? Aren't you happy that you don't have to by heart this? That is like the most stupid thing that anybody can do is actually sitting and by heart, and many teachers actually tell that please by heart this, by heart this. No, you don't need this. Take the history of NEET, take the history of JEE, take history of JEE Advanced also, most toughest exam. Over there also they don't ask such questions. What they ask you instead is what is it proportional to? That is very important. The radius is proportional to n square by z. N square by z. That's all you should remember. And that constant of proportionality in this case happens to be 0.53 and then n square over here by z Armstrong. This is what you are supposed to remember. That's all. That it is proportional to n. N is quantum number, principal quantum number. Z is atomic number. This is in Armstrong. That's all. Got it? And also you just need to know this. Velocity is proportional to z and inversely proportional to n. That's all you need to remember. Nothing else is needed for solving NEET problems or even board problems. If they ask you, if they ask you for this n, this was the radius, for that n, what is the radius? You are just going to use the proportionality constant. We'll see some problems based on that. Okay, great. Now that you have understood it, now you'll be like, sir, what about the energy? Well, we'll talk about the energy also. When we see that there is an electron, going around in an orbit around the nucleus, what all kinds of energy can you think of? Put it up in the chat box. When I say the energy of an electron, when I say energy of an electron in orbit, what kinds of energy do you think are there with it? Yes, Sarvana, I definitely know, bacha. I teach with him on JEE English channel, right? Yeah. What are the different kinds of energy? Yes, Ashika. You can remember the constant, but generally they don't give you such questions on constants. Kinetic energy. Centripetal, no. Centripetal is not a form of energy. Centripetal is a force or acceleration. Yes, Malvika, very good. Kinetic and potential energy. There is nothing called as centripetal, guys. Please understand that centripetal is not a form of energy. Centripetal force is there. Kinetic, because it is moving. It is moving. So motional energy means kinetic energy. Because this is a charge, this is a charge. What will happen whenever there are two charges? Electrical potential energy. Electrical potential energy. So hence there is kinetic energy because of the motion, and also there is potential energy. Kinetic energy will be half mv square, correct? And potential energy will be 1 by 4 pi epsilon naught q1 q2 by r. This is the formula for potential energy. When you substitute everything and you add them, this is what you get. This is what you get. The energy in the nth orbit comes out to be minus 13.6. Minus 13.6. Here you get z square and downstairs you get n square. But the answer is in electron volt. This is the formula for the total energy of the electron in the nth orbit. This is the nth orbit. I hope this is clear, guys. Everyone with me? Clear? Okay, this is the formula. 13.6 z square by n square. Why that negative sign? I'll come to that in a bit. For now, just remember there is a negative 13.6 as a constant. Also, one more crucial thing that you should remember is that this kinetic energy of that electron is exactly the negative of this total energy. It's exactly the negative of this total energy, number one. And number two, the potential energy that you get, is two times of the total energy of that electron. These are also some of the crucial things that you should know regarding kinetic or potential. So if you know total, you can find kinetic or you can find potential. You can find both of them using this. And this formula is right over here. Okay, double, and this is just negative of this. Very important. Kinetic energy is negative of total. Potential is double of total energy. These are the important formulas that you should know. Okay. Now, why is it negative? We'll come to that. Why is that energy negative? See, actually what happens is when you draw a chart or a graph of the energy of that electron, for differentials, this is how it's going to look like. This is basically your K shell, then you're going to have your L shell, then you're going to have your M shell, then you're going to have your N shell, and so on and so forth. Many shells will be there, and the last shell will come over here. What is it called? I'll come to it. The K shell has a principal quantum number n is equal to 1. This is n is equal to 2. This is n is equal to 3. This is n is equal to 4. What is the last number that you can get, guys? 1, 2, 3, 4, etc. What is the last number you can get? Let's see. Guys, think of the largest number possible. Everybody knows what is the largest number possible? What is the largest number possible, guys? K, L, M, N. 1, 2, 3, 4. What is the largest number? Infinity, right? Very good, Madhumita, Sandhya, Leaf. Very good, Prem. Excellent aim, MS Doctor. Very good, Lydia. Very nice, Ashika. Very nice, Dhanuraj. Very good, Shagun. Excellent aim, my warriors. Lenasis, Sumita. Very good. So here, n tends to infinity. Now when n is infinity, you will be like, what is this, sir? New orbit is there. Actually, you know what it is? It's so far. It's like useless. It's like a useless electron. The atom will be like, what the hell, man? You are so far. You might as well not stay with me. It's as good as you're not there. It's like saying that, you know, you are not inside the house. You are somewhere really far. You are really far. It's as good as you're not having any kind of relationship, or you do not have any kind of talks. You do not have any kind of feelings, or you do not have any kinds of relations in the house. You're just really far away. That's it. You're not bound anymore. So this is a free state. What is it called? Free state. It's free. Electron is free. This energy, when it is free, is 0. Here, the energy at infinity principal quantum number is 0. This is the highest value of energy. So obviously anything below 0 will be negative. So all these will be negative energies. Negative energies. In these cases, it is bound to the nucleus. It is bound to the nucleus. Here, it is not bound. It is completely free. That's when n is infinity. Is that clear? So that's why it is negative. If it is more negative, it is more bound. So keep this in mind. More negative means more bound to what? To the nucleus. It is very much attached to it. So if it is more negative, now don't get scared. It's good only. So more the negativeness, more is that attachment towards the nucleus. Yes, but only fixed orbitals. Yes, only for fixed values you can get these energies. You cannot have random values of energies. That's why these lines are there, guys. That's why these lines are there. Any trick to memorize the energy values of the bands? No, Prem Kumar. I mean, you don't have to remember all the values. Just remember 13.6 and 10.2, 3.4 and all of that. The first 2-3 values more than sufficient. Don't sit and by heart for KLMN till Z. No, don't do that. Just first 3 values more than sufficient. Okay? Everybody with me on this? So that too for hydrogen, because see, if it is helium or lithium, then again the energy values will change. Okay, so more negative energy, Sandhya, more negative energy, very, very important, more negative energy, meaning of out of minus 13.6 and minus 10.2, who is more attached? Who is more attached? Come on, put it up in the chat box. Come on, put it up in the chat box. Who is more attached, guys, to the nucleus? Who is more attached out of these two? Obviously, this has more attachment. This one is less bound. This one is less bound. Is that clear? Very nice. This is what I mean by it. This is more negative, this is less negative. So this will be somewhere here, this will be here. So as you go up, the negativeness will reduce, slowly it becomes 0. Very nice. Now, if I have some kind of electron over here and I send it to infinity, if I have some electron over here and I send it to infinity, the energy required to send that electron to the highest state, that means to make it free, the energy required to free the electron, what is that energy called? What is that energy called? Okay, if you don't remember the name, it's okay. Think like this. If the electron is plucked out, what will happen? The electron is plucked out. What will happen to the atom? It's deficient of an electron. What is that atom now called? It is an ion. It is now an ion, right? It's become an ion, right? So the energy required to make it an ion will be ionization energy. It will be called as the ionization energy. That's all. So imagine if over here the energy of the electron was minus 13.6. Just imagine. If I pluck out that electron and bring it here, how much energy do I have to give? Put up the answer in the chat box. If I pluck out that electron which had minus 13.6 electron volt and bring it to 0, how much energy do I have to give? How much energy do I have to give to that electron to make it free? How much energy do I have to give? From minus 13.6 to 0. So plus 13.6. Exactly. So that ionization energy will be basically negative of that energy in that orbit. So if it was minus 13.6, it's minus of that. So it becomes plus because that's the energy which you give it. Very nice. I hope this is clear. Okay, so this is again one crazy formula. Are you going to sit and by heart this? Are you going to sit and by heart this, or are you going to remember this formula? Okay, no, right? You're not going to remember this. This is just there in your books. This is just to scare the kids in the night. okay, or even during the day. This is the one which you're going to remember. Okay, this is the formula in electron volt. Keep this in mind. Okay, maybe we can solve some questions based on this. Come on, guys, get ready. In which of the following systems will the radius of the second orbit be minimum? Out of all the orbits, out of all the atoms, where do you think the radius of the second orbit will be minimum? The meaning of second orbit means KL, L shell, L shell. In the L shell, what is the value of n? N is equal to 2. Okay, why different atoms are given? Oh, their Z will be different. Acha. What has the radius got to do with Z? Think like this. Radius is proportional to n square by Z. N square by Z. N is it is inversely proportional. Z is below, R is on the top. So inverse relationship. So if denominator increases, radius will decrease. So who has the biggest Z? Who has the biggest Z? Obviously this one. So this is max value of Z, hence least value of radius. But if the question said maximum radius, then what will be the answer? Right now the answer is B, yes. But if the question said maximum, then what will be the answer? Think like that. Think like that. If the question was maximum radius, Z will be minimum. Z will be minimum. Very good, crazy followers. MS Dr. Madhumita, very good. Epic Queen Deva, very good, Shagun. Then the answer will be H atom, hydrogen atom, because that has Z is equal to 1. Very nice, guys. Moving on to the next question, guys. Very good, guys. You guys are thinking a lot and you guys are carrying it along. You're playing along with me. That's fabulous. This is how you have to attend the classes. Very good. Keep it up. I'm 100% seeing so many students acing NEET now. Keep it up. Calculate the principal quantum number for which the radius of the orbit of the electron in B3 plus would be equal to ground state electron of hydrogen atom. Okay, so this is not a part of the question. Just ignore this. Okay, let's try to solve the question, guys. First of all, okay, what is given is the radius of the orbit of the electron in B3 plus. In which radius? For which radius? I don't know that. So radius of the nth orbit in BE, okay, in B3 plus should be equal to the radius of the ground state. Ground means below, right? What is the least possible value? N is equal to 1. So the radius of the first orbit in hydrogen. The radius of the first orbit in hydrogen atom will be some constant, don't worry about it. And here, remember, always radius is a constant into n square by z. So over here for hydrogen, n is 1. So instead of n, you're going to put 1. For hydrogen, z is also 1. So just put 1 over here. For BE, what are you going to put, guys? First of all, put constant over here, and n value I do not know, so just put n. What is the value of z that you are going to put? What is the value of z that you are going to put? What is the value of z that you are going to put, guys? Come on. The value of z that you are going to put is 4, right? B has z is equal to 4. Very nice. Constant and constant cancels. Constant and constant cancels. So you just have n square by 4 is equal to 1 by 1 is just 1. So therefore I just have n square is equal to 4. So n is equal to 2, guys. N is equal to 2. That is the answer. Where is it? Option A. Excellent. Very good, Roshni. Very good, Madhumita. Very good. So many of you answered Z was 4. Very good, Sri Sandhya. Sampad, it was not 3, it was 4. Excellent, guys. Wow, very good. So I think you are getting confidence now. Let's see if you can solve this question as well. The potential energy of an electron is this. Then what is the kinetic energy? You will be like, sir, you just told that this formula is not important. Yes, it is not important. Just read the question again. You will understand why it is not important. If potential energy is this much, what is the kinetic energy? Very good, Shagun. You answered it first. Very good. I think Shagun has answered the next question also correctly, really quickly. Very good. And let's see whether you guys are correct or wrong. What did I just tell you? Potential energy is 2 times of total energy. And kinetic energy is negative of total energy. What you do now, you just divide these two. Just divide these two because I want to find relationship between potential and kinetic. So potential energy by kinetic energy will be minus 2 by 1. That's it. So from this, what do I get? Kinetic energy will be minus 1 by 2 times potential energy. Now it is clearly mentioned what the potential energy is. It is minus E square by 4 pi epsilon naught R. Minus minus becomes plus, it will become E square. 4 2s are 8, 8 pi epsilon naught R. That is your kinetic energy. Where is that option? Where is that option? Option B. Excellent. Not C. That minus sign gets cancelled. If you make a calculation mistake, you will get minus and also minus negative mark also. B for Bombay. Very good. Divide by 2, multiply by minus. Excellent, Sumita. Yes, that's how it is. Very good, NH Sandhya, Vijay, Velsi, Madhumita, NH Deva. Very good, GV. Very good, Sarah. Very good, Vijay. Very good, Kanan, Epic Queen. Very good, Sampath. Very good, MS Doctor. Excellent, bacha log. Okay, now let's go to the last and final few parts, and that is basically the hydrogen spectra. So this is one of the important things about Bohr's model, that it was able to talk about the spectrum of hydrogen and many such elements. Now, what is this spectrum? The spectrum is like a signature of an atom. Like you guys have a signature and it is very unique, right? Unless somebody deliberately tries to copy it, it's a unique signature. Same way, every element has its own sign. If you call hydrogen, it'll be like, hey, listen, this is my signature. If you call lithium, it has its own signature. If you call iron, it has its own signature. Now, what does this signature look like? You might be wondering. It is not like the sign that you are expecting. It is in the form of spectral lines. It is in the form of lines or colors which are very distinct or which are not continuous, but they are separate, they are discrete. Looks something like this. Looks something like this. You can see these lines over here. Something is missing over here. And you can see some lines over here as well. Some lines here as well. So these are the signatures. So I know you guys were thinking like, oh sir, there will be a nice signature over here. No, these are lines which are there or not there. This is called as a spectrum of line. Lines are there. Continuous, somebody was asking some time back, sir, what is the meaning of continuous and line spectrum? Continuous means it's continuously there from one point to the other. There is nothing missing, it's not in steps. This is line spectrum. You can see that. One line, second line, third line. If you take some other atom, these lines will be at different places. Number of lines could be also different. So for every element, these lines are different, differently placed, and it is unique. No two elements will have the same spectrum. Understood, guys? Every guys have copied their parent sign in childhood for leave. Yes, for getting leave, for report card especially. You know, report card, exactly. Like fingerprints also. Yes, very true. Yes, acing, I'll be doing semiconductor in just one session, but it will be a very big session. Are you ready for that? Pakka, you will be able to stay for 3 hours, everyone. Yes, crazy fellows, soon. But for now, at least concentrate on physics and chemistry. And for bio, as of now, if you want in Tamil, then you have the Tamil channel. Or if you want, the Hindi channel is also there. And if you also want a little bit of English and very little of Hindi, then you also have the biotonic channel. Yes, you will be able to stay. Acha, kya baat hai? Very good. Okay. Now, what is this spectrum dependent on? It's basically due to the electron transitions. Remember some time back, where did it go? Right over here. Yeah, see? An electron can absorb the photon and get excited, or it can release the photon and then it can get de-excited. So when a spectrum is formed because of absorption, what will it be called? Absorption spectrum. Obvious, right? Very simple. If a spectrum is formed because of photons, that means light is absorbed, that means the electrons get excited, that spectrum will be called as absorption spectrum. Correct? And if a spectrum is formed because photons are getting released, when will it get released? Because electrons are getting de-excited. Then it will be called emission spectrum. It will be called emission spectrum. Okay, let's try this out. Okay, let's go to absorption and emission spectrum and see how this works again. Over here, just look over here. Here, do you see something is missing? Do you see things missing? That means what has happened, guys? That means what has happened? Absorption has happened. Absorption has happened. So definitely one can say that light photon was absorbed. Photon was absorbed, and because of that, the electron has gone to higher energy state. So the electron jumps and it gets excited. Very, very simple. That's why you can see missing lines. In the other case, do you see lines are only there at certain places? When will that happen? When will that happen? Like you can see over here, the electrons basically get de-excited. De-excited. That is going to release. What is it going to release, guys? It's going to release photons. What is it going to release? Photons. Dual nature was done in the first session only, Nidhi. The first session had dual nature. Okay? I think you have missed that. Please check it out. It was there somewhere in between. First part we did photons, then wave particle duality. Last part was photoelectric effect. Everyone fine? Now, the manner in which these transitions happen, they have certain names given to it. So there are series name. So if the electron jumps, de-excites from higher energy to the lowest energy, which is n is equal to 1, those lines are called Lyman series. What are they called? Lyman series. If the electron de-excites to n is equal to 2, those transitions which emit photons, those are called as Balmer series. If the electron jumps from higher energy states and gets stuck over here to n is equal to 3, then those photons which come out, they are in the Paschen series. If the electrons jump to n is equal to 4, then the photons which come out, the light which comes out, that belongs to Bracket series. How have these names been given? They have been named after the person discovering these series. Discovering these series, or who have made experiments to show these series. Lyman, Balmer, Paschen, Bracket. Let's see if you can answer this question. When I say the first line of Balmer series, from what to what transition am I referring to? First line of Balmer series, from what to what transition am I referring to? Let's see quickly if you can answer this. Yes, there are higher series like P-Fund also, but this much is enough for NEET physics, trust me. Why did Lyman not find other series? I don't know, Dhanuraj. I'll have to go back in time and ask him. Lyman, why did you not find others, man? You just had to draw these lines. It looks so simple. But guys, those times are different and it's not easy to find it experimentally. Here you can draw the lines, but actually finding it experimentally, difficult. Yes. So guys, Balmer series first line will be from 3 to 2. 3 to 2. This is second line. This is third line. This is fourth line. This is fifth line. If I say first line of Paschen series, that will be n is equal to 4 to n is equal to 3. If I say last line of Lyman series, Lyman is here, last line is here, don't say 7, no, it's actually more, from infinity to 1. From infinity to 1 is the last line of Lyman series. Everyone get it? No, not 7 to 1, crazy fellows. I knew many of you like, sir, in the diagram it is 7 to 1. Understand, in the diagram I have not shown other lines, 8, 9, 10 till infinity. So infinity will be somewhere here. So from infinity to 1, that will be the last line of Lyman series. Got it? Everyone? Excellent. This is how the naming works. Now every transition is associated with an energy. So I'll just put it up over here maybe. Do I have some space somewhere? Oh my god, I don't have space. I'll just write it over here then. Okay guys. See, when the energy changes from one level to another level, then the change in the energy of the orbit, like I told you before, is associated with the energy of that particular photon. The energy of the photon is hc by lambda. Energy difference of that orbit I can use minus 13.6 z square by n1 square minus 13.6 z square by n2 square. All this is in electron volt. You make all the conversions, solve this. Everybody understood this step? Energy difference of the orbit, this orbit and this orbit, this orbit and this orbit. N1 and N2 are just the numbers, 3, 4, 5, 6, whatever it is. Minus 13.6 z square by n1 square, minus 13.6 z square by n2 square. When you take these numbers, solve it properly, then you get 1 by lambda. 1 by lambda is equal to, you will get some constant, you will get z square, and here you will get n1 square, and here you will get n2 square. Here you will get n1 square and here you will get n2 square. This constant is basically called as the Rydberg's constant. The symbol for that is R. I'll show you the value as well. And this is the formula which you're going to remember. I just put it up over here. Okay, I just put it up over here as well. You can see. Don't have to remember this. There is no need to remember this. This is the actual formula for the Rydberg's constant. Do not remember, not needed at all. This is what you are going to remember. 1 by lambda is Rydberg constant, 1 by n1 square minus 1 by n2 square. Let me put up over here as well. Just one second. Okay, this is z square. That's all you're going to remember. And the value of the Rydberg's constant, roughly 1.1 10 to the power 7. 1.097 will be more accurate, yes, but you can also write it as 1.1 into 10 to the power 7. That's okay. Yes, it looks like X-ray spectrum. Yes, it is. It is. In fact, X-rays are very much related to these spectrums as well. Okay, so this is a formula, but remember it is 1 by lambda, not lambda. Lambda is there below. Okay, and z square is there on the top. All right. Don't have to remember all of this. Okay, so I'm just putting a cross over here. Do not remember all this. Just remember these values over here. This is more than sufficient. This is more than sufficient. That's all. Okay. Let's move now to the last part of Bohr. Even Bohr failed, guys. Even Bohr was not able to explain certain things. So after that came, orbital theory, and then quantum theory, where you had orbitals. There were no fixed orbits. They were in the weird shape. There were probabilities and all of that. So that is the newest theory, but we do not have that. You have studied brief about orbitals in chemistry. That's about it. But you should know why Bohr's model failed. Because it failed, it violated Heisenberg's uncertainty principle. Number one. Number two, it said that you can precisely locate where the electron is, where the momentum is, how much. So it was violating that. And also it was not applicable for higher elements. For hydrogen it was okay. The moment you go to carbon, even lithium or even helium, the calculation of radius speed was wrong. So that means something was wrong in the assumption of Bohr. So it failed for higher atomic numbers. Third is, it was not able to explain Zeeman effect, which is basically when you put magnetic field, there is splitting of spectral lines. Why do the spectral lines split? There was no explanation for that using Bohr's model. So that's why Bohr's model failed. Very important 3 reasons. Very important 3 reasons. Yes, only for hydrogen it worked, and even in hydrogen there is actually a 4th point. In hydrogen, when precise calculations were done, even for hydrogen it did not give exact value. There was a small difference even in hydrogen. So guys, that's why Bohr's model had some flaws, but still we studied because it gives a good idea of how things work. The last question of today's lecture, guys, the wavelength of the first line of Lyman series is lambda. The wavelength of the first line of Balmer series is how much? Zeeman effect, Sandhya, is nothing but the spectral line split when the presence of magnetic field is there. Meaning, do you see these spectral lines? These lines over here? If you apply a magnetic field, that means you bring a magnet, this line splits. This line splits. Why is that splitting happening? No explanation. So Bohr was not able to explain that using his model. That is Zeeman effect. Splitting of spectral lines when a magnet is bought. Okay? Cool? Alright. if it is wrong, why questions were asked from this topic? Dhanuraj, these are theories. It gives you a good understanding of how other things were working. Number one, whenever a theory is there, it explains certain things, it does not explain certain things. That's what the constant battle of a student is. Correct me if I'm wrong. You are always like, sir, in projectile motion, you ignored air resistance, sir. Then why are we studying this? Blah, I'm not going to study this. That's not you're going to say. So think of it this way, guys. Maybe you're not able to see the bigger picture now. Just imagine a first standard student saying, or first standard student just learning addition and subtraction. Little does he know that addition and subtraction only half the times you can use. So many times you have to use derivatives and integration. If you go and teach him derivatives and integration, because this is reality, right? You need derivatives and integration for most of the complicated or most of the explanations. He will stop studying, quit. Just like Quit India movement, he will quit studies. Like, sorry boss, 1 + 1 = 2 is good enough for me. What is this derivatives and integration? Same way, if you guys start seeing everything now, you'll be like, sorry sir, NEET, tata bye bye, I'm going sir. So that's why. Okay, chalo, the correct answer for this is option A. Most of you got it, GV, and somebody said D. No, it's not D, it's A. Let's see why it is true. The wavelength of the first line of Lyman, that means 1 and 2. So basically 2 to 1 transition. If you talk about first line of Balmer means 3 to 2. Okay. So over here, 1 by lambda 1 will be RZ square. Okay. Is basically 1 by 1 square minus 1 by 2 square, 1 square and 2 square, n1 and n2. Similarly, 1 by lambda 2 will be RZ square, 1 by smaller number first, bigger number later on. That's it. Now just divide the two. Just divide the two, guys. Just have to divide this with this. That's all. You will see many things will get cancelled, like RZ square and RZ square. You will have lambda 2 on the top and you will have lambda 1 below. Okay, that's what you're going to get. And on this side, what are you going to get, guys? Here you will have 1 minus 1 by 4, 1 minus 1 by 4, and here, because this is downstairs, here it will be 1 by 4 minus 1 by 9. Now just solve this till you find the value of lambda 2. Find the value of lambda 2. Just check this, solve this and see if lambda 2 is 27 by 5 times of lambda 1. 27 by 5 times. Just solve this. Okay, this I leave it up to you. Very good. Any relation between voltage, low pressure, diffraction grating, line spectrum and all of that? So MS Doctor, well, there are certain phenomena affecting, the spectrum because of other things, but we do not study all of that for NEET bacha. Don't worry about all those things. Just limit yourself till here. Okay, so guys, you are going to get the PDF, my handwritten notes in the Telegram channel. Make sure you join it. Okay, the official link is there in the description box. This is your homework question. Everybody who has attended this session should mark your attendance, because that's the only way you're going to mark it apart from the chat box. If you're watching it recorded, even if you're live, how do I know you guys are putting that effort? You have to put up the answer in the comment section, guys. This is your homework question. Second homework question this is. And yes, if you want more questions and if you want the test series, the link is there in the description box for the crash course as well as the test series. Test series only has tests if you are okay with only tests. But if you want test series plus doubt solving, plus classes, plus assignments, plus further assistance, then go for the crash course. Thank you very much, guys. I hope you had very, very good learning experience out here. Make sure you stay subscribed on the channel, and also make sure you like the session because it motivates me to conduct more such classes. Thank you very much. Do not forget to leave a comment and put up nice answers over there. Even if your answer is wrong, it's okay. Just put up the answer. It shows that, okay, fine, you are at least trying. Okay, so I don't care about whether you got the right answer or wrong answer. You're just trying. That's what is very important. Okay, bye bye, guys. Hasta la vista. I'll see you guys on Monday or Tuesday, where I'll be doing problems on these two chapters. Come prepared. Hasta la vista. Take care. Bye bye. Signing off.